Hello everybody, my name is Ervin M. Skau and I'm a researcher at INRINU Center of Excellence in Slovenia. I use life cycle assessment to investigate different strategies or parameters to reduce the environmental footprint of wood and engineered wood products. As you probably all know, we have to drastically reduce our emissions of CO2 and other greenhouse gases to prevent dangerous climate change. This graph from the Intergovernmental Panel on Climate Change shows how the global community needs to come down from currently about 40 billion tons of CO2 to net zero and below around year 2050. Not only climate change and COVID-19 is a health risk. Here I show how yearly deaths caused by one type of air pollution, respiratory inorganics, or emission of small dust particles, in blue, contribute to deaths in some European countries and compare it to the COVID-19 death toll per 26 June in red. As we see, most European countries have a much higher death toll from air pollution than the coronavirus. Another difference is that air pollution, to a much higher degree than COVID-19, caused deaths by the youngest, especially children below 5 years. Therefore, in a quest to reduce greenhouse gas emission, other air pollution, and other environmental impact, I use the life cycle assessment method. This slide shows the life cycle of wood construction products. The colored processes are within the cradle-to-gate system boundary. Also transport, energy production, and other raw materials and products like resins are included. Here I show the 7 strategies I investigated to reduce the environmental footprint of glulam and OSB. Number 1, low glue consists of reducing the amount or environmental impact of resins by 20%. Number 2, modal shift train consists of loading timber on train instead of truck and ship. Number 3, local supply of wood, where production of glulam and OSB is nearby the wood source. Number 4 is to use clean electricity. Number 5 is to use only biomass, no natural gas or oil for heat production. Number 6 is to reduce the wood raw material input or the environmental impact thereof by 10%. This could, for example, be recycled wood. Strategy number 7 is called a combined strategy and consists of strategy 1, 3, 4, and 6 for glulam and 1, 3, 4, 5, and 6 for OSB. This slide shows the resource for glulam. The spider diagram shows the reduction potential measured in percentage for each strategy for different environmental footprint impact categories. For climate change, ionizing radiation, eutrophication of fresh water, and research use energy carriers, the reduction potential is about 60% with the combined strategy, the clean electricity being the most promising strategy. The respiratory inorganics impact category is difficult to reduce. In total, only 10% reduction is achieved with the combined strategy of several measures. This slide shows spider diagram results for the oriented strand board. A 50% reduction potential is possible for climate change and ionizing radiation with the combined strategy. The land use impact category is difficult to reduce for oriented strand board. Conclusion. Life cycle thinking shows opportunities for environmental impact reduction. Up to 60% reduction was shown here when combining several reduction strategies. Reduction is possible with only small or no change in the production, which I call low-hanging fruit. And here are some references. Please also have a look at the conference proceedings for the full paper with all references, also available at Zenodo. Thank you very much. I will be glad to have some questions. Bye.